Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Steel SMEs are facing significant challenges in green hydrogen feasibility studies. This presentation explores the knowledge gaps that are blocking the hydrogen transition. The steel industry is a major contributor to global greenhouse gas emissions, accounting for 8% of the total. Achieving net zero emissions is impossible without transitioning to clean steel production. Green hydrogen, produced from renewable electricity and water, is a promising solution for the steel industry. It replaces coal in direct reduced iron processes, enabling near-zero emissions in steelmaking. Large players in the steel industry, like ArcelorMittal, Saab, and ThyssenKrupp, are moving fast with large-scale pilots and substantial government and investor support. Despite being the backbone of the supply chain, small and medium enterprises, SMEs, struggle to progress beyond feasibility studies in the hydrogen transition. The failure of these projects is often due to knowledge gaps rather than technological issues. Understanding these gaps is crucial for successful hydrogen transition. SMEs often fall into predictable traps, such as underestimating certification requirements, glossing over market access risks, miscalculating technical needs like water purity, and relying on weak financial models. Certification is a non-negotiable aspect that is often overlooked by SMEs. It involves rigorous measurement, reporting, and verification processes that are essential for project success. The Section 45 volts tax credit offers up to $3 per kilogram of clean hydrogen, but it comes with strict conditions that must be met to qualify. Certification requires rigorous measurement, reporting, and verification, revenue-grade metering, registry tracking of hydrogen attributes, third-party audits, and hourly matching of renewable power from 2030. Large corporations factor certification requirements into their studies from the start, while SMEs often assume access to tax credits without outlining compliance, leading to an awareness gap. SMEs often struggle with weak market access analysis, failing to adequately address market barriers and pathways, which is crucial for successful project implementation. Starting in 2026, steel exported to Europe must include verified emissions data or face additional tariffs under the EU Carbon Border Adjustment Mechanism. While large firms are already building CBAM compliance into their business models, many SME studies fail to mention it at all, highlighting a preparedness gap. Policy volatility, such as changes to the 45 volts tax credit, poses significant risks to projects. Feasibility studies that assume stable policy conditions appear dangerously naive. Technical missteps, particularly in water quality, are a major challenge in green hydrogen production. Ensuring the right water quality is crucial for efficient and cost-effective operations. Not just any water will do for PEM electrolyzers, they require ultra-pure water with conductivity and chloride levels in the parts per billion range to function effectively. Without proper water quality, electrolyzer stacks degrade faster, output drops, and maintenance costs rise, underscoring the importance of water quality in hydrogen production. Larger developers incorporate purification systems into their feasibility budgets, while SMEs often calculate volumes assuming municipal supply will suffice, leading to a water planning gap. Safety codes and regulatory compliance gaps are critical issues in hydrogen production. Addressing these gaps is essential for safe and successful project implementation. In the world of hydrogen safety, understanding extensive safety requirements is crucial. With storage above 10,000 pounds triggering OSHA PSM and EPA RMP, it's essential to navigate the regulatory landscape effectively. Federal, industrial, and design requirements all play a role in ensuring safety, with specific standards like NFPA 2 and ASME B31.12 guiding the way. Safety planning reality differs significantly between large companies and SMEs. While large companies have comprehensive safety planning with dedicated teams, SMEs often adopt a minimal compliance approach due to limited resources. This disparity highlights the need for tailored safety strategies across different business sizes. Financial models for green hydrogen projects often suffer from weak assumptions. The framework for financial modeling includes capital expenditure, operational costs, and other factors, but the levelized cost of hydrogen, LCOH, is a critical metric that can be miscalculated, leading to flawed financial projections. The levelized cost of hydrogen, or LCO, represents the total cost per kilogram of hydrogen produced over a project's lifetime. Unfortunately, SMEs frequently underestimate key components or rely on outdated assumptions, which can skew financial outcomes and project viability. Financial modeling reality also varies between large companies and SMEs. Large companies engage in sophisticated modeling with multiple scenarios and sensitivity analysis, while SMEs often use simplistic models with optimistic assumptions and limited variables, potentially leading to inaccurate financial forecasts. Outdated standards present a significant problem in the hydrogen industry. While CGA updated its hydrogen standard in 2024 and NFPA and ASME codes were revised in 2023, many SME studies still reference 2019 editions or older, leading to compliance and safety risks. A common thread across these challenges is a lack of structured education. Root cause analysis reveals gaps in financial model calculations, market access risks, and CRM unawareness, all stemming from insufficient educational frameworks. The education reality shows a stark contrast between big companies and SMEs. While big companies have teams of specialists and structured training, SMEs often enter complex sectors without adequate preparation, highlighting the need for improved educational resources. The solution lies in accessible, structured education that helps SMEs understand frameworks and anticipate requirements. By addressing knowledge gaps in financial model accuracy, market access strategies, and CRM compliance, SMEs can achieve successful implementation and reduce risks. H2 Hub provides a unique blend of education and action. Through professional courses in green hydrogen development, SMEs learn to avoid feasibility traps and connect with vetted consultants, reducing investor risk through better preparation. Education is not a cost, it's leverage. Key takeaways highlight the challenges SMEs face in green hydrogen feasibility studies due to knowledge gaps. Problems span certification, market access, technical, safety, and financial domains. The common thread is a lack of structured education and preparation. H2 Hub offers the education and connections needed to succeed, inviting SMEs to transform their approach and join the next cohort for successful green hydrogen implementation. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening.